So we did our project on the Great Basin National Park. I'm Colin Westfall.
I'm Ailey George.
And I'm Kathleen Doherty. Here's a video, a short one.
Up from Broad Valley, and ancient trees cling to life through summer storms and winter snows. A place of breathtaking caves and glittering night skies. A high desert landscape of dramatic vistas and surprising gifts. Untold treasures await your discovery at Great Basin National Park.
So first, the Great Basin is pretty big. It covers 5 different states, Nevada, Utah, Oregon, Idaho, and California. The national park is just located in Nevada, right about here is where the national park is. Largest area of contiguous endorheic watershed, which what that means is that there is no outlet for the water to get to the ocean. So they receive 7 to 12 inches of precipitation a year, and all of it either evaporates or flows into some other form of, like a well or a stream or something like that. By receiving 7 to 12 inches of precipitation, this makes Nevada the driest state in the country. The Great Basin has 2 different types of deserts. There's a hot desert and the cold desert, and I should point out that both of the deserts are hot. It's just one of them is pretty much always hot. One of them, the cold desert, is hot during the day, but then at night there's a rapid drop in temperature. This is because of the high elevation. The cold deserts have a much higher elevation than the hot deserts. So it's kind of like when you look at a mountain and you see the mountaintops, how they're covered in snow. That is kind of what's happening here with the cold deserts. So the precipitation for the cold deserts, a lot of it comes from snow, and then obviously the hot deserts receive most of the moisture from rain. An example of the hot desert is the Mojave Desert, and the cold desert, an example of one is the Great Basin Desert. The heat there, it's not like here, it's a dry heat, so like I said, the relative humidity is low. Like I said, dry heat. Rapid temperature drops at night, specifically in the cold deserts, but it can happen in the hot deserts as well. And a lot of that has to do with the relative humidity being so low. In the summer, the climate there, it's not uncommon to get really severe afternoon thunderstorms. Why it was made a park, as you saw in the video, there's a lot of different topography and wildlife. There's caves, forest deserts, just a bunch of different things like that. They recognize that it has potential to bring in a lot of tourists, which then would help in the economy, bring in some money. What they used it for a while was mining. And it was either kind of hit or miss for the year. It would either be, they had a good year of mining or a not so good year of mining, so their money was it was either they got a decent amount of money or not a lot of money. So they wanted a way to kind of steady that out. So making this a park kind of gave them a steady source of income. Like I said, it has an attraction to tourists just because of all the different aesthetic, educational, and scientific values that are there.
This is a geographic map of the Great Basin, or part of it. And the highest point is down here in the southwest corner. It's 13,000 feet. And then up at the top, it's 6,000 feet. And that's the older alluvium. And down here is more like the granite and biotite granite. And here's a cross-section of part of the Great Basin, and it's important to note that there's a lot of normal faults within it, like right here. And most of it happened during the Paleozoic era. And here's another cross-section. And this shows why there was normal faults, because there was expansion during this time because of the heating of the rocks right here, with the volcanic rocks. And then to the right, or the west, there's subduction, which also caused the normal faults. Here's the stratigraphic column. It ran from the Neoproterozoic to the Cenozoic, and most of the rocks happened between the Neoproterozoic and Paleozoic era. And there was no rocks formed during the Permian and Triassic periods. And it went from quartzite, shale, limestone, and then there was no rocks formed, no new rocks formed. And then muscovite, biotite, and conglomerates, and more volcanic rocks formed. Some history was most of the rocks formed during the Cambrian period, which happened during the Paleozoic era, and that's where the dikes and sills happened. And there was extensive volcanism after this, which happened to be the conglomerates, ash flows, and tuffs. As mentioned, there was many faults, which makes it so mountainous in this area. And Nevada is one of the most seismically active states. And the faults are usually found at the base of the mountain range in the Great Basin. And the basin and range topography is caused by the movement along the fault. And as the mountains grow, fault block activity, the earthquakes occur. And normal slope displacement are bound and uplifted, and which causes the tilted mountain ranges. There's a lot of earthquakes that happen in this area. Here's the Great Basin, and this is all the earthquakes that happen around it. So it's pretty active in this area. Also, there's a glacier in Nevada, which is like one of the only ones in the southern United States. And it occurred in the Pleistocene, and it is heavily eroded peaks of Snake Ridge, which is a 60-mile range in the Great Basin. And it resulted in canyon walls, U-shaped valleys, and cirques and moraines. It's called the Wheeler Peak Glacier. It's an alpine glacier because it's not that small in comparison to other glaciers. And it's protected in a cirque around 11,500 feet in elevation, and its size is 120,000 square feet. And it's important because there's a lot of rocks within this glacier, like limestone, marble, sandstone, shale, quartzite, granite, and gypsum. And it's not going to be there in 20 years because it's evaporating so fast. And here's a picture of it. It's kind of blurry, but it's down here. That's all those cirques. Snake Range, the glacier is found in the Snake Range, and it's a really long mountain range of 60 miles, and it includes two peaks, southern and northern, and it's made up of sand, mud, minute ooze laid down on the bottom during the Precambrian and Cambrian eras.
Okay, so now just to key into a few more factors of the Earth history. Volcanic rocks formed about 30 million years ago and have been cut and displaced by the block faults. Racks, or as we refer to them as faults, bound the blocks, and the uplifted parts have been eroded over geologic time, as we saw. And one more key factor is pretty obvious, but it's imperative. Minerals have proved to be the greatest resource of the Great Basin. Looking at the aesthetic beauty and the geologic features of everything, we have to keep in mind that there are still potential hazards of this region and of any national park. The four key ones in this region are fires, more specifically wildfires based on natural causes, invasion of non-native species, humans, because let's face it, we're a threat to the environment, and earthquakes. The two that I'm going to key in on are fires and invasion of non-native species. So the first one, fires. Pinwan and juniper environments have unfortunately expanded into the sagebrush grasslands, which were native. And so sagebrush is now unfortunately decreasing. That, combined with wildfire size and frequency increasing every so often, is a cause for more non-native species to unfortunately come in and ruin what the native environment that it had. Things that are being done for this are the ecological restoration projects put into place. What they do is they seed selectively and they cut trees and they chip and spread slash everywhere. And another thing that they do is duplicate vegetation, which basically means that they try to recreate the original environment. The other one, non-native species, which as you saw kind of went along with fires, natives extinction reduces biodiversity basically means that the biodiversity in the Great Basin National Park is decreasing every day, unfortunately. Human actions are also a main cause of this. Contaminants that can be brought in by anyone who goes into the park, and also hikers are a big part. They could have contaminants carried, or non-native species carried on any of the apparel that they bring in. And also, non-native species are spreading rapidly, approximately 400 acres per day. Keeping all of this in mind, unfortunately, this stuff does happen, but we just want to, hopefully, more projects will be put into place for this kind of thing. Thank you.
Other questions?